Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will start new topic questions based on new topic, that is the collision frequency and mean free path. Last class I have discussed question answer and explanation based on kinetic molecular theory of gases and deviations from ideal behavior. This topic completely finished. Now I am going to start question answer explanation based on collision frequency and mean free path. Now I am reading the question. Question number 64. Collision frequency of a gas at a particular pressure. 4 option is given. First option, decreases with rise in temperature. Second option, increases with rise in temperature. And third option, decreases initially and thereafter increases. Fourth, unpredictable. Again I am reading the question. Collision frequency, that is the Z, capital Z, of a gas at a particular pressure. 4 option is given. You have to tell correct option. First option, decreases with rise in temperature. Second option, increases with rise in temperature. Third option, decreases initially and thereafter increases. Fourth, unpredictable. Now we think this question is not difficult. It is easy only. Just to think. Its correct option is B, that is the increase with rise in temperature. Increase with rise in temperature. Why? Now I am giving explanation. Collision theory, collision frequency at a particular pressure increases with temperature, because if you increase the temperature, then gaseous molecules will move fast and it will collide more. It will collide more among themselves also or on the wall. Then obviously collision frequency, what was actually supposed in 1 second, only 2 times was colliding with wall of the container. Now because you have increased the temperature, then now speed of the molecules will be more. Hence now it will collide in per second. Now it will collide more than 2. Correct? Hence correct option is B only. That is increases with the rise in temperature. Collision frequency Z of a gas at a particular pressure increases with rise in temperature. Now next question I am reading. Question number 65. The closest distance between the centers of 2 molecules of a gas taken part in collision is called. First option, molecular diameter. Second option, collision diameter. And third option, both. Fourth option, none. Again just you first I will tell, again I will read the question, then you can answer. Okay. Now again I am reading. The closest distance between the centers of two molecules of a gas taking part in collision is called, first option, molecular diameter. Second option, collision diameter. Third, both. Fourth, none. Just to think, I think you can answer. If you have studied this topic, then you must answer. Just to think. Its a correct option is both. Both are correct. Option A and option B. Both are correct. Molecular diameter, also you can tell collision diameter. Now actually, what is actually diameter? Molecular diameter or collision diameter, what is? Then now I am telling you. The closest distance between the centers of two molecules. The closest distance between the centers of two molecules of a gas taking part in collision is called molecular diameter or collision diameter. Closest distance between the center of two molecules, molecules A, molecules B, and center of molecules A and center of molecules B. Just to distance between these two, A, center of A, molecule A, and center of molecule B, that distance actually is called molecular diameter, because R plus R, correct? For two molecules, for one molecule is a small radius, for other also radius, then both you are measuring, then two radius. Two radius means diameter. Then this actually is called collision diameter, also called molecular diameter. And the correct option is both, that is the option C. Now next question I am reading. If the mean free path is A, small a, at 1 atmospheric pressure, then the value at 5 atm pressure you have to tell. First option 5A, second option 2/5A, third option A upon 5, fourth option unpredictable. Again I am reading the question, listen carefully. If the mean free path is A, small a, at 1 atmospheric pressure, ATM, then its value at 5 atm pressure is, first option 5A, small a, that is the mean free path. Second 2/5A. Third option A upon 5. Fourth option unpredictable. It is conceptual, just to think. Its a correct answer is A upon 5. A upon 5, that is the option C. Why? Then now I am telling you. When gas is compressed from 1 atm, means atmospheric pressure, to 5 atmospheric pressure, means pressure increased 5 times. When gas is compressed from 1 atmospheric pressure to 5 atmospheric pressure, the distance between the molecules is reduced. Because in the beginning molecules were far, but now pressure has increased, then molecules will come closer. Closer means distance will decrease. Then how much it will decrease? Then distance between the molecules is reduced to 1/5, because you have pressure is increased 5 times, hence distance will reduce to 1/5, and so is the mean free path. Correct? Mean free path. Then this the correct option is option C, A upon 5. Correct? Actually mean free path is a distance. Then here due to the pressure distance will decrease. Okay. Now next question I am reading now. Question number 67. Actually that you know that molecules will collide. Correct? Then average distance between the two collisions continuously, when 2 times it will collide, then how much distance it will cover? Average distance between the collision you can tell, between the two collision. Then that will be the A upon 5, because distance will decrease by 5 times. That's why now distance will reduce to 1/5, means A upon 5. Next question 67 I am reading. If the collision frequency of a gas at 1 atmospheric pressure is Z, then its collision frequency at 0.5 atm is, means half atmospheric pressure. First option 1.0 Z, second option 0.25 Z, third option 2 Z, fourth option 0.50 Z. Again I am reading the question. If the collision frequency of a gas at 1 atmospheric pressure is Z, collision frequency, then its collision frequency at 0.5 atm, means now pressure is reduced. In the beginning it was 1 atmospheric pressure, now it became half, means 0.5 atm. Then what will be the collision frequency? You have to tell. Collision frequency is denoted by capital Z. 4 options are there. Then first option is 1.0 Z, second option is 0.25 Z, and third option is 2 Z, and fourth option is 0.50 Z. Again option I am telling you. First option is 1.0, second is 0.25 Z. All are in Z only. First is 1.0 Z, second is 0.25 Z, third is 2 Z, fourth is 0.50 Z. Just to think, I think it is also conceptual, you can answer it. Just to think. Now its correct option is 0.25 Z. Its correct option is 0.25 Z. Why? Now I am giving explanation. You have to remember the expression of collision frequency. Only then you can solve it very easily. Collision frequency. What is the collision frequency? Then collision frequency is equal to, that is the Z is equal to 1 upon root 2 upside pi V sigma square n square. This is the formula. Z is equal to 1 upon root 2 upside pi V sigma square n square. Then by this expression you can tell Z is equal to n square, proportional to n square. Other things you can consider as a constant. 1 upon root 2 pi V sigma square, all are fixed. By expression you can tell that Z depends upon n square. Other things take it as a constant. Then Z is directly proportional to n square, where n is the number of molecules per cc, number of molecules per cc, correct? Here n is the number of molecules per cc. As pressure is reduced from 1 atmospheric pressure to 0.5 m, means half, then what will happen? N decreases to half the value. Just you listen carefully that Z is proportional to n square. And what is the n? N is the number of molecules per cc, cubic centimeter, number of molecules. As pressure is reduced, becoming less, that is from 1 atmospheric pressure to 0.5. 0.5 means half. Then what will happen? Pressure you have reduced, means now gas will move fast. Actually, a number of molecules which was present in 1 cubic centimeter, due to high pressure it was more. But now pressure reduced, then gas number of molecules will decrease in 1 cc. In 1 cubic centimeter, number of molecules will decrease because gas will go outside. What was within 1 cc, now because gaseous molecules become free, then in now 1 cc number of molecules will be less, correct? Then this is the main reason. Then how much actually Z will value? Then number of molecules will decrease. Hence Z will become 1/4, because Z is proportional to n square. Then now because it has decreased, pressure has decreased, it become half. Then now Z will become 1/4. That is 0.25 of the value of 1 atmospheric pressure. When it was 1 atmospheric pressure, that time value was Z. Now it became 1/4 because pressure became half. Then half square means what? 1/4. 1/2 whole square. 1/4. Then now its correct option is 0.25 Z, option B. Now next question I am reading. Question number 68. The mean free path of a gas molecule is the distance. First option, distance between the two opposite wall of the container. Second, which the molecules travel in 1 second. Third, through which a molecule moves between two consecutive collisions. Fourth option, none of these. Again, I am telling you, I am reading the question. The mean free path of a gas molecule is the distance, first option, between the two collision, between the two opposite wall, between the two opposite wall of the container. Second, which the molecules travel in 1 second. Third, through which a molecules move between two consecutive collisions. And fourth option is none of these. Just to answer, I have given hint in the previous question when I was discussing. Now think, I will tell the correct answer. Its correct option is through which a molecules moves between two consecutive collisions, continuous collisions. That distance actually is called mean free path. Mean free path of a gas molecule is the distance through which a molecules move between two consecutive collisions. Okay. Now I am giving explanation. That is actually this is direct answer only. Mean free path is the mean distance, average. Mean free path is the average distance travelled by a molecules between any two consecutive collisions. Any two, their average value. Correct? That is called mean free path. Then today I am stopping only here. Next class again I will continue with other topic. Okay, thank you.